Okay, here we go. So here's the deal. Basically, every day I'm going to check off like classwork, basically. So you're going to get a grade for today. So at the end of class, I am just going to ask to see your notes. So I do expect you to write these down. You can just like flash them to me quick on your camera, or if like I had some people whose cameras weren't working, you can always scan it with a phone and then email it to me. But basically, every day you're just going to get like a quick little grade just that you participated. So make sure you're writing these down. And once again, if you have any questions, I got the chat open. I got you guys here. You can always interrupt me. But it's just like that question. So we'll just go through them quick. But then if it's a beat home, I don't need to wear a mask and I can drink tea all day. Okay. So let me see. We'll zoom skiing. We got a little bit of angle here. I was writing at a weird angle in that class. Okay. So question one. So all of these have to do with adding or subtracting fractions. We call those rational numbers. And the main thing with rational numbers is you need a common denominator. So finding the common denominator first, changing your numerators, combining things, and then seeing if you can simplify anything is going to be kind of your main goal of every problem. So if I were starting with a problem like number one, my first goal is I need a common denominator. So if you just have numbers, or in this case, we don't really have any binomials like more than one term, you just kind of see what they have in common and you make sure everything's in your denominator. They both have a 4, so in my common denominator, I need a 4. Okay. This has a b squared, so I'm going to need a b squared. This has an a, so I'm going to need an a. I said it like that because I need to write it alphabetically or it will drive me nuts. So I'm going to write it as ab squared. So that's my common denominator. I make sure everything that I see here is represented and I'm good. But now I need to go back and change my numerators. So the 4 is all set. The b squared is all set. I did have to multiply that by a to get to that common denominator. So I'll do the same thing up there. And I would end up with 5a squared. All right. Here I have the 4 and the a. I'd have to multiply it by b squared. Same thing to the numerator. And then I decide, well, okay, what else can I do? Well, I can write one new fraction. I can put the common denominator, and I can add the numerators. Those are not like terms, so that's okay. You just kind of keep it as 5a squared plus 2b squared. And then from there, there's not much else you can do, right? Nothing's factorable. You can't reduce anything because they don't all have something in common. So this would be your final answer. And with every problem, you are going to write domain restrictions. Excuse me, hiccups. So we can't have our denominator equal to 0. So there would be two restrictions in this case. We would say a cannot equal 0, because if I threw a 0 in here, it would make the whole thing 0. And I would also say b cannot equal 0. Just for the same reason, if I put a 0 in for b, it would make the whole denominator 0. So just make sure you're always writing those main restrictions. So that's your first one, kind of more basic, nothing too crazy. Main goal, finding that common denominator, changing the numerator, and going from there. Any problems? I'll take that as a no. Okay, so we're going to keep trucking along here. So number 2. So let's see one where maybe the denominators are a little different. So in this case, we're saying, all right, no common denominator, let's find one. But before I do that, I do need to factor. So that first fraction, I'm going to factor the denominator. It ends up being 1 over, and that's like a difference of 2 squares, x plus 2x minus 2. And then over here, we have that. Okay. So my common denominator, I just make sure everything's right. So I need an x plus 2. I need an x minus 2. I just kind of go through each denominator with what's in there, making sure it's represented. And I say, oh, x plus 2, but I already have that, so I don't need to write it again. It's already represented, so I'm good. So I say, do I have to change the numerator? In this case, it's no, right? Because that's the same as that, so that just stays as 1. And in this case, I have x plus 2, so I would have to multiply by x minus 2 to get to the common denominator. And I'll just do my quick little distributing, and that gives me 6x minus 12. And now I can finally actually add them. I'm just combining my terms here. So I have 1 plus 6x minus 12. That just gives me 6x, right? There's no other x terms. And then the 1 plus negative 12 will give me minus 11. In this case, that's not factorable. Nothing's going to cancel or reduce. So I think I'm just done. We would write our restrictions that x cannot equal -2 or +2. So always remember those restrictions. And that's your second type. So you kind of were finding the denominators, and they did have something in common. So you just kind of keep that in mind, and just making sure everything's represented. Any problems on two? We'll also take that as a no. Lovely. Thank you so much. Okay, number 3. Once again, these are all, like, I handpick these. So if these are looking good, like, you're going to be good for that assessment tomorrow. We're not trying to kill you on the assessment. You know, life is stressful enough at the moment. All right, number 3. Okay, so we have this problem. We're saying we need a common denominator. There's actually 2 things you can do, and it's really just preference. You can either say, oh, I'm going to factor this and go from there, and then just find what they have in common and make sure everything's represented. Or if you notice, I could just take this denominator and multiply it by 3 to make it that. You can also do that as well. And it's going to get you the same answer. So it really is just preference. So I'm going to make my common denominator 3m plus 6. Once again, if you want to do it in the factor form, I'm going to do that in a second anyways. This would stay the same, but once again, this second fraction I did multiply by 3, so that would be 12m. So then as I go through and combine, I keep the denominator. I subtract the numerators in this case, so that would give me negative 11m. And I'm saying to myself, there's really not much I can do, but I always like to factor that denominator, so then I can tell my restriction a little bit easier because I see that m cannot equal -2. So then that would just kind of be my final answer. So sometimes you will be able to kind of go and say, oh, there's a common factor. I can, cancel it out. And sometimes you can't, just kind of done. But always make sure I like to put the denominator as factors. It's a little bit easier to tell what the domain restriction is. All right. But once again, you could have kind of started 2 ways. You could have either factored it, or if you just saw that you can multiply one to get to the other, that works as well. Any questions on 3? We're halfway through that. We're chugging along. We're doing good. All right. GeoA. Okay, let's see. B minus 4. Oh, b squared plus 2b minus b plus 2 over b squared minus 16. All right, so I'm looking, I'm saying, all right, there's no common denominator to start. I need to find one, but in order to do that, I do have to factor those denominators. Okay. I'm getting lazy with my writing too, so I'm just going to kind of factor it right below, so I don't have to keep writing this problem. I'm writing all day, guys. Gosh, what a life. So what would that factor to? B plus 4b minus 2. And then this would factor to b plus 4b minus 4. Okay, so now let's find the common denominator between those two. I need b plus 4. So I always kind of write it in both just so I don't lose it. I need b minus 2. Is that right? Yeah, sorry. Then I need b plus 4 already there, so I'm good. But I need b minus 4, and that is not represented yet. So I'm going to throw that there. So I don't know if we had done a ton where, you maybe had more than 2 binomials. So that can happen. However many you need to represent what's there, have that many. There's no limit. So now let's look back. This had the b plus 4 and the b minus 2, so I would have to multiply this by b minus 4. And then just remember as you do this, when you're multiplying 2 binomials, you're distributing. So that would give you b squared. And then you would end up with minus 4b minus 4b, which is minus 8b. And then plus 16. Sorry, I'm always at a weird angle. And then over here, I have b plus 4 and I have b minus 4. I'd have to multiply by b minus 2. Same thing with the numerator. Once again, just a distributing problem. And that would give me b squared. I would end up with minus 2b plus 2b, so I wouldn't have just a b term because they cancel. So I'm going to write it. And then that would be minus 4. Okay, so at least, now we have a common denominator. Things are kind of simplified. Now we can actually finally subtract. So that's always our main goal, actually combine them. So I feel like a lot of these are just a lot of rewriting here, but we'll just do our best. And we will combine numerators. B squared, make sure you're subtracting, minus B squared cancels, right? There's no more B squared. Negative 8b minus, there's no b term over here, so that just stays as negative 8b. Okay, that's fine. And then we have 16, just be careful because it's minus and negative, so you are adding 4. So that will give me plus 20. Okie doke. I can factor the top, right? There's a GCF. We're going to make it negative 4. Yes, it takes a lot of thought these days. That will leave me with 2b plus 5 over that denominator. That's right. And that's it, right? That doesn't cancel, that doesn't cancel, nothing's reducible. I can give my domain restriction that b cannot equal negative 4, 2, or 4. Besides that, that's my final answer. I feel like, I'm sorry. I feel like a lot of times we tend to second guess ourselves as well and we just get a gross answer. So don't, because they happen. So just do your best to, um, I don't know, do your best to do. Sometimes you're going to know your answers. That's life. Okay, this next one, I know that one very, very similar pops up. And then there's one more I wanted to show you that we haven't actually done yet. It's like 2 steps you know how to do type deal, but I'm going to show you how to do it just as a heads up. It's only a multiple choice, so it won't tell you either way. But so this one. Okay. This situation pops up all the time. We talked about it before, where you kind of like you look at the denominator, they look really similar, but they're not quite the same. And so you do have to do a little bit of rearranging and just making sure that they are exactly the same when you get the common denominator, and then going from there. So that's m minus 9. I'm going to keep that. But this one's 9 minus m. We like to write things in standard form, so we're going to write the negative m plus 9. And then we say, well, oh, that's so similar. It's just the signs are different. So we are going to take out that negative 1, like a GCF of negative 1, and that will make it m minus 9. And now we're feeling a little better about life. So when I find my common denominator, I know there's going to be m minus 9 there. But in this case, I also have to put this negative 1 in the common denominator. So when you're rearranging and you're doing stuff like that, you just have to include in the common denominator as well. So in this case, I did have to multiply this by negative 1, so I would have to do the same thing to the numerator. That would give me negative 2 plus 5m. If you wanted to switch the order of that just to make it standard form, go for it. This is the common denominator, so the numerator, excuse me, yeah, the numerator stays the same. I can't talk today. Let's combine here. We have our denominator. We're going to combine numerators with like terms. 5m plus 4m is 9m. Negative 2 plus negative 5 is minus 7. That's it. M can't equal 9. We're done. Sometimes, like on a multiple choice or something, sometimes if you have a negative here, it might be like out in front. So just something to look for. If there's a negative, it doesn't really matter where it is as long as it's somewhere in the problem. So just sometimes, depending on the program, some people like the negative on the front. So just as a heads up on that one. But that's the last main question you will see. So what happens when you get tomorrow's quiz? Our setup is going to be right when class starts, I'm going to post the quiz on Google Classroom. So you'll come and we'll do attendance and that type of thing. And I'm just going to say get started. For tomorrow, I will expect your camera to be on. So it doesn't need to be on you. I more need it on your workspace. I just want to see that you're like not on your phone, you're not looking up answers, you're not texting people to get answers type deal. So once again, you can just like take it and kind of just put it at your workspace so I can see it working. You'll have the period to complete it. When you're done, once again, you don't need to print it. You can just do it on a separate sheet of paper. It's just a bunch of problems. It's nothing too exciting with the setup. When you're done, just make sure when you scan it, it's like a legible scan. I feel like sometimes I get ones like for assignments. I'm like, yeah, I can like tell that you did it, and I can like see a little bit. But like for a quiz, I do want to see the details. So just make sure you do have a good scan, and then you'll just email it back to me. Or actually, you can just attach it back to your thing, not email me. That will just take up all the money in my inbox. So that will be the thing for tomorrow. I'll give you all those directions again, but that will be kind of the idea. So there's one more problem I wanted to do with you. It's one of the multiple choice. So 1 out of 12 questions, and it's only worth 2 points, but I'd rather just have you see it. So here it is. It's kind of combining a few things that we did. So technically, you probably could do it without me telling you, but I always like to help you out. I never want to assume you know how to do stuff. I'm going to show you the way you know how to do, and then I'm going to show you a shortcut. So this is the problem. That's called a complex fraction because we have fractions over fractions. So we want to simplify it. That's what it's going to say. Let's simplify. Okay, we don't want fractions over fractions. That's ugly. What you would do is focus on the denominator to start because you can't do 10 things at once. So focus on one thing. We'll focus on the addition part because that's what we've been doing. So if I focused on this, I would say, what's the common denominator of just down here? And it would be x plus 1, x plus 4, right? Because I need to represent both denominators. Okay. If this was x plus 1, I had to multiply this by x plus 4. So I just end up with this. If this was x plus 4, I had to multiply this by x plus 1. And now I could combine them, having my common denominator and adding the numerators. That would give me 2x plus 5. Okay. Sorry, I'm just trying to not rush. Sometimes I tend to get into problems and I like those stuff. Okay. Now remember that's the denominator of a fraction. So I know that's kind of weird. So what we really are saying is 1 over this. So still not the prettiest thing because we still have fractions over fractions. So if you could see it, that would be even better. But we know how to do this because we know that when we divide by fractions, we multiply by the reciprocal. So we keep the 1 the same because that's the numerator. And then we are dividing by 2x plus 5 over x plus 1, x plus 4. And with division, we know it changes to multiplying by the reciprocal. Okay? So now 1 times this is just this. So this is your answer. Cha, 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 cha. We would say x couldn't equal negative 5 over 2, right? Just on that. I think on the thing, it also might distribute that out. So it would say x squared plus 5x plus 4. And you guys can do that in your head. But let me show you the shortcut. So technically that was stuff we knew how to do. We knew how to add in the, you can see it, add in the denominator. I kind of did that as a separate problem. Once I added, I reminded myself that that just meant division. And to divide fractions, I'm just multiplying by the reciprocals. So another way you can do this problem is if you take the original, and like back when we were, I don't know why I just did that. Back when we were doing this, we said, oh, the common denominator is x plus 1, x plus 4. Once you find that common denominator, you can multiply everything by it. So every term. So every term gets multiplied by x plus 1, x plus 4. You're going to see the magic that's about to happen. Oh gosh, okay. So what are we left with? In the numerator, we're just left with x plus 1 times x plus 4. Once again, you can distribute that out, and I think it might do that on the multiple choice. So just as a heads up. On the bottom, here's what happens. The x plus 1's cancel. You're left with x plus 4. Plus, you have a plus in the middle. The x plus 4 is canceled. You're left with x plus 1. So in your final answer, you have your numerator. And then your denominator would just combine my terms to get 2x plus 5. And just like magic, it was the same as our other answer, right? It's just a different way to do it. So you can always multiply everything by the common denominator. And that'll kind of take care of some of those fractions for you, and then it just makes it a little bit easier. The other way, there's just like an extra step or two. But once again, it's stuff you know how to do. It's just kind of putting it all together. That was a lot of talking. So that's my spiel for today. So we had like 5 problems that we went through. They basically all pretty much relate to a problem on the quiz or assessment. So just relook those over and then make sure you're feeling okay. And then this one was just, once again, it's a multiple choice, so it's 2 points. So it won't kill you either way, but I at least wanted to show you one. So as of right now, do you guys have any questions or anything else that you would like to go over in more detail? Either throw it in the chat or just say it. Okay, I'll take that as a no. So give me 1 second. I'll either like turn everything off. It's such a mood. Okay, no, go away. Okay, give me a second here. I'm sorry if anyone is actually watching this. I'm going to stop presenting.